I'm going to try solving these using the quadratic formula. In our first case, first thing I might do is add a 1 in front of my x squared so that I don't get confused, because then we know that a is equal to 1, b is equal to 2, and c is equal to negative 36. The quadratic formula is going to be negative b, so negative 2, over 2 times 1 for a, plus or minus the square root of 2 squared minus 4 times 1 times negative 36, all over 2 times 1. The first part's going to turn to negative 1, because negative 2 over 2 is negative 1, plus or minus. We get the square root of 4, and 4 times 1 times 36 is going to be plus 144. I think. Yeah, that sounds about right. All over 2. So we get negative 1 plus or minus the square root of 148 all over 2, and you can leave your answer like that if you'd like. For the second one, I've got to do a little bit of work first, and by that I mean I got to take 4 away from both sides. We get 9x squared plus 18x minus 24 is equal to 0. I'm kind of regretting my choice of colors here. Let me see if I can get a better one. Okay, I might take a look at this and realize that I can make this better numbers if I divide everything by 3. And I get 3x squared plus 6x minus 8 is equal to 0. That's a really handy trick to make this an easier problem to solve. So we've got a is equal to 3, b is equal to 6, c is equal to negative 8. So quadratic formula, negative b, so negative 6 over 2 times 3, plus or minus the square root of 6 squared, minus 4 times 3 times negative 8. And that's going to be all over 2 times 3. Negative 6 over 6 is going to be negative 1. Plus or minus 36 plus, because we have 2 negatives in there, and then 32 times 3 is going to be 96 all over 6. So negative 1 plus or minus the square root 36 plus 96 is going to be 132 over 6, which does not reduce much. And that would be your final answer. Looking at this guy, I'm going to solve this using the quadratic formula again. I've got to bring everything over to one side. I'm going to make this 7x squared. I'm going to add 5x to both sides. I'm going to subtract 11 from both sides and get that equal to 0. So a is equal to 7, b is equal to 5, and c is equal to 11. When I plug this in, we get negative 5 for b over 2a, which is 14. So 2 times 7. Plus or minus the square root of, that's going to be, sorry, c should be negative 11 there. B squared to be 5 squared minus 4 times 7 times 11, all over 2 times 7. Negative 5 over 14, plus or minus, and this is going to be over 14 as well. Square root of 25, and 4 times 7 times 11 is going to be, should be negative 11, plus 298. So we get negative 5 over 14, plus or minus the square root. When I add those two things together, I get 323 over 14, and we're done. The next one says to solve most efficiently. I'm not sure what way that is, so if we bring everything to one side, 5x squared plus 1x minus 84. I have a feeling this is factorable, just because the numbers that are there, but I'm not sure that I really want to go there as far as trying to figure that out and quadratic formula might be the best way to avoid that. So A equals 5, B equals 1, and C equals negative 84. So negative 1 over 2 times 5 is 10, plus or minus, that's going to be over 10 as well, the square root. 1 squared minus 4 times 5 times negative 84. Okay? So we get negative 1 over 10 plus or minus the square root. 1 minus 4 times 5 times negative 84. Well, that's going to be 20 times negative 84, or 680, 6,800, 1680, that's it. So it's going to be 1 plus 1680 is going to be 1681, which happens to be a perfect square. I'm going to end up getting 1 over negative 1 over 10 plus or minus the square root of 1681 is going to be 41. I could leave it like this, or if I wanted to, I could add those pieces together and come up with a really nice answer.